so we have this other question, which is asking us to express the force in Cartesian vector. It's asking us to express the force into a Cartesian vector. So this is very simple. So the only thing that is very important here is just finding the unit vector. So first of all, before you find the unit vector, you need to first find the vector or the coordinates in Cartesian. You first have to find the Cartesian coordinates of A. You also find the Cartesian coordinates of B, and then you find the vector directed along A and B. And then to find that, you need to find the unit vector in the direction of AB. After finding the unit vector in the direction of AB, you simply just multiply it with the force to get the magnitude of this force in Cartesian form along the same AB. All right, so let's do that. So the first thing that we do is we find the coordinates of A. So the point A, or the Cartesian coordinate of A, is simply just going to be, so in the X, we're moving from that point to that point. So this distance is 2 there. If you check, so we have 2 in the X, so we have 2i. And then from there, we also have in the Y. In the Y, we don't have anything. It's just in the X. So A is just in the X. So in the Y, we have 0, J. And then in the Z, we're moving from there. Okay, so one thing we have to understand again here is the direction. Okay, first let's pick the points. Then I'm going to explain about the direction later. So let's pick the points. So we have 2, and then we have the Z there. We are moving from there to 4. So we have 4. So we have 4, we have positive 4 there. Okay. And then the Cartesian coordinates for B they are going to be B there. We have B, we're moving towards the negative 2 units. So we have negative 2 in the X, and then in the Y, we're not moving any distance. So rather in the Z, we're not moving any distance, but in the Y, we are moving, do we have Y? Yes. So in the Y, we are moving 7 units. So we're moving 7 units, 7 meters in the Y. So we have positive 7 J, and then in the Z, we're not moving any because we don't have this any distance going up. It's just at 0. So we have plus 0K. So to find the vector AB, the position vector of AB, you simply say B, or simply say OB minus OA. So OB minus OA. So we're subtracting this minus that, this minus that, this minus that. So our position vector AB is therefore going to be, so negative 2 minus 2, we're getting negative 4i. Then 7 minus 0, we're getting 7j. And 0 minus 4, we're getting negative 4. Okay. So after finding this vector, the next thing that you need to find is the unit vector along this same vector, or the unit vector of AB. So the unit vector of AB is therefore going to be equal to, we write the same 4i plus 7j minus 4k. Then we divide everything by the magnitude of this same vector, which is just going to be like that. And then from there, we can simply find this. So we have 16 plus 16, which is 32. 32 plus 49 gives us 81. The square root of 81 is going to give us 9. So we have negative 4 over 9 plus 7 over 9 minus 4 over 9. So I have j we have I, and then we have K. So this is the unit vector along this AB, the vector AB. So this is the unit vector in the direction of AB. So now, after finding this, the next thing that we are going to do to find the Cartesian vector for this force, we have to multiply the unit vector by the force. So therefore, the Cartesian vector for this force, we're going to say 900, or let me write the formula. It's important to see the formula because we don't forget formulas easily. So we are going to say the force times what? Times the unit vector in the direction of AB. So we're going to have the force being equal to, so we have 900 multiplying by the unit vector there, negative 4 over 9I plus 7 over 9J minus 4 over 9K. So when you do the multiplication there, discover that what you're going to get will be negative 400, because this 9 and that 9 will cancel, and that 9 there will cancel, we'll just have 1 there, and you have 2 zeros there, which is 100. Okay, so the other thing that we need to, okay, we have a 400 there, then this one is going to be plus 700 J, then we have a minus 400 K. So this is the unit, rather this is the force, this is the Cartesian vector of this force. All right, do we have any questions on this question? All right, so it seems like the time is even up. I'm supposed to start teaching the first years from UNZA, from Apex. Let me end the meeting, and then we'll proceed in the next meeting that we are going to have for statics. Or if not that, then I'm going to make the tutorial videos to solve the other questions that are remaining. See you in the next lesson. Shalom.